So, greetings everyone. Let's go over some of the homework problems 5.3. And again, so far we have not really seen many methods, only one method which we will explore, which we explored in the lectures today a bit more, or in the next few lectures. But they suggest to us how to solve this. And they say, so in this particular one they say, okay, this is a, let's analyze what we have here. We have a second order because of the y prime. There is only, oh, this is a y prime, right? I copied that wrong, I think. Let me just go back to the actual question. Just, sorry, I want to make sure that I copied the right problem here. Yeah, that's a y prime. Oh, it's xy prime. I brought, okay, x prime doesn't make sense. Sorry, let's copying error here. So it is second order, this y double prime. It's linear because it only has a y prime and a y in it, no powers, no mixed term, nothing else. It's non-homogeneous because this part would otherwise be zero. Is it, we talked about constant coefficients. Is it constant coefficients? No, because we have this x square here, right? Now, technically, of course, we would divide by x square to solve for y double prime. That's what we normally do, but it's sometimes not necessary to do. It gets uglier by doing that. You're creating fractions or negative exponents, so let's not do that. Now, so the suggested solution, I say this is something that we will we have discussed much more in detail in 5.4, but the suggested solution here is that it would be a multiple of that of this forcing function we call, and the only thing that we then have to find is is there a solution, capital A. We just want to find one particular solution. We're not trying to solve the general solution because that would require us to solve also the homogeneous solution, which we don't have techniques for. Okay, so let's do this. So what we do, so this is our suggested solution. What we have to calculate is y prime and y double prime. So y prime is a half a x to the minus a half, right? Subtract, we're taking derivative, so the subtracting powers, and y double prime is take derivative of this guy, so that is minus 1/4, right? Another minus a half comes out, a x to the minus 3/2. Now let's plug everything in. So we plug this guy in here, this guy in there, and of course this guy in here. So what we get? We get x squared minus 1/4 a x to the minus 3/2 minus 7x a half a x to the minus a half plus 7a x to the power a half, and that is equal to 13x to the power a half. Now, a lot of things have to happen for this to work, and let's see. Let's simplify things here a little bit. So we have minus 1/4 a. Now, product of powers is adding the exponents. 2 minus 3/2, that is a half. To the next here, right? X to the power a half. What do we have here? We have minus 7/2, we have an a, and then we have x, which is power 1, plus minus a half. So that is again a half. And here, of course, we have 7a x to a half, and that is equal to 13x and a half. Now, what has to happen, otherwise it doesn't work, is that this all must be like terms, and this is x to the half. They all have the same power here. So this means, in other words, we could, if you want, simplest way to say that is just, let's divide out x and a half. Okay, so we find minus 1/4 a minus 7/2 a plus 7a is 13. So we put this all in common denominator. We see we can factor out an a here. So we get minus 1/4 minus 14/4 plus 28/4. So putting everything in the common denominator is 13. So we find that a is 28 minus 14, that is 14, minus 1 is 3rd, or we get 13/4 equals 13. Now, look how nice. So this means that a is equal to 13 times cross multiply, right? 4 13s, that cancels, so a is 4. And so the solution is 4a to the power, not e, x to the power a half, right? So we just plug in a in our suggested solution here. Okay, not hard, right? But be cheating in some senses that they tell us it's gonna work. Most of the time, it is not gonna work. Okay, so we'll discuss this in more details when and how and so on. But for now, we just accept the magic. Okay, the next one was number 12, yeah, and number 12 is x squared y double prime plus x y prime plus y equals 10 x to the power 1/3. Okay, again, let's take the suggested solution. If we're lucky, it's of the form, it's a multiple of x 1/3, a constant multiple. So it's not really variation of parameters here. So yeah, perhaps I should point that out here. So here we think of a as a constant. We're trying to find a solution that is a constant. Now, in the variation of parameters, we put a u there, and that becomes much more complicated, right? There's much more terms then that we would have to deal with, and that's something for later. But for now, we just do, so this a is a constant, and we just hope that there is some constant that makes this work. Okay, so y prime is then 1/3 a x to the minus 2/3, and y double prime is then minus 2/9 a x to the minus 5/3. Okay, so we plug this in, we get x squared minus 2/9 a x to the minus 5/3 plus x 1/3 a x minus 2/3 plus y, which is a x 1/3, is equal to 10 x 1/3. And again, a kind of magic has to happen that we should only have x to the power 1/3, so that we can cancel that away. And that is exactly what happens, right? So we get minus 2/9 a x to the power 1/3, right? This is 6/3 minus 5/3. Here we have 3/3 minus 2/3, so also 1/3. Plus 1/3 a x to the 1/3 plus a x to the 1/3 is 10 x to the 1/3. So we divide by x to the 1/3. Of course, if x is 0, we cannot do that, but that's just one point where x is 0. We know that there are always going to be problematic points, but most points, of course, that doesn't. All non-zero points, we have no problem, so we can do that. So we get a, let's figure that out, minus 2/9 plus 1/3 plus 1 equals 10. Put this on common denominator. We see that this is minus 2/9 plus 3/9 plus 9/9. That is 12. That is 10/9. So this is 10/9. So we get a is 10/9. A times 10/9 is 10. So we cross multiply. We see that a is equal to 10 times 9/10, which is 9. So solution, y equals 9 times x to the 1/3. So if you do this, by doing this, you probably notice why this worked. Notice that in both cases, we have, the coefficients are different, but we have an x squared in front of the y double prime, an x in front of the y prime, and a nothing instead of the y. And here the same thing, right? And that is why this works. That is why if you have a single power here, this single power, it doesn't matter what this power is, it will always work here. Because think about it, when you take the derivative, you lower the exponent by 1, multiplying with x, you add another 1 to it, so you kind of cancel each other out as far as the exponent of x is concerned. And the same here, you take the double derivative, you subtract twice in the power rule, twice, and you subtract 2 from the exponent if you do it twice, and therefore by multiplying with x squared, you bring it back to the original one. So that is why this type of differential equations can be solved that way. But if this is not of this form, and I think, I don't know whether I assigned or not, but for instance, question 7 gives you, problem 7 shows you that it's not always the case. This doesn't always work. Okay.